So the next section, activity timeline, is what corresponds to what I've shown here. So this activity here, this activity graph shows you the number of active sessions per sample time, and basically the this information is in principle more interesting in case of parallel execution. In case of serial execution, of course, there's not too much to expect from this section, because you at most can see an active sessions of 1. But as I will show in a minute, it can still be interesting even for serial execution, but in particular for parallel execution. This is a very useful information because it gives you an idea about the busyness of your parallel servers. So in principle, if we, for example, operate at a degree of 3, then we would like to see at least 3 parallel slaves being active most of the time. So this section here now in principle is similar information. It gives you information. You have here a timeline, so start of the execution of the SQL statement to either the current time if it's still executing or until the end of the execution. You also get here, depending on the version of Oracle, you also get from the active session history information about the PGA usage and the temp space usage, which in principle corresponds to these metrics here. So you see here the PGA and the temp usage here, and the graph here includes this information already. So this is the same information here about PGA and temp in the same. Then you just get here information about how many of these samples were on CPU, how many were not on CPU, and the average active sessions, then basically the total. And for that you also get a graphical representation here. So probably this column here is the most crucial information for this section here. So you see here the activity. Again, you see here these @ signs basically represent the CPU activity, and the asterisk represents the non-CPU activity, so that you can see here there is some difference in activity, which corresponds to the different colors that you see here. So here green is CPU, whereas this blue is in this case here then user I/O. So this corresponds to the asterisk here in the graphs, in this graphical, in this cheap graphical representation. Some of the things that you do not get that easily from real-time SQL monitoring is the top active plan lines. So you see here for each sample point you also get the list of the top, I think 3 or 5, which you can configure in the script configuration, the top n top active plan lines, which sometimes can be very helpful to understand which lines of the execution plan were active. In 12c you actually can request this here by using this drop-down box. In the real-time SQL monitoring you get here this plan line breakdown, which is more or less the same information. So we see here the same line 23 and line 35 and so on, which should largely correspond 23, 35, 17 and so on to what we see here. This information here is not available in the 11.2 version of the real-time signal monitoring, there is no drop-down box, so you can't request that from the real-time signal monitoring before 12, and in 12c you get this option by plan line. In Xplan-Esh you get this for all versions that support plan line relation of active session history. So starting from 11.1 you get this information here. Another information that can be quite interesting is you see here the active DFO trees. So we can see here that this DFO tree number 1 of the execution plan, so this part here that belongs to this temp table, transformation DFO tree, this DFO number 1 here, DFO tree number 1. And this is also reflected here, that you see here that DFO tree number 1 is active. In theory, as I've shown you in other parts of this tutorial, it's possible that multiple of these DFO trees could be active at the same time. Then you would get here a comma-separated list of DFO trees along with the degree. So the meaning of these different numbers is this is the DFO tree number 1 in square brackets, as you see here in the column header. In the square brackets you get the degree of this DFO tree. As you might know from different tutorials, from other tutorials, you might know that different DFO trees could operate at different degrees. So that's the reason why I show here the degree for this DFO tree. So DFO tree number 1 operates at a degree of 3, and in the parentheses you get then the average active sessions. So operating at a degree of 3 and running with an average active sessions of 3 is good. If it looks more like here, if we operate at a degree of 3 and we have only 2 or maybe just 1 slave active, then this indicates that there might be a problem with the work distribution. So that's the reason why this information is again here repeated. And if you have more complex plans where multiple DFO trees are active, then this total active sessions also then will be split up accordingly across the different DFO trees that might be active at the same time. The information here about the CPU and non-CPU activity is then again in more detailed available in this top activities column. So you see here we just have a pure CPU activity in this case here, and in this case here then we see we have non-CPU activity indicated by these asterisks here, and you see here now this is then this direct path retemp. So basically the detailed information about what kind of non-CPU activity this is you get from this column here, and again this more or less corresponds to this resource type breakdown here. So this direct path retemp, write temp, what you see here from this graph you get here from this column here. So you get more details if you have a mixture of CPU and non-CPU activity, then like this here. And this list here is comma-separated list is then always ordered by the top activity. So the ones that have the most samples assigned will come first, like here 3 samples on CPU and 2 samples on user I/O, which gives you then in total average active sessions at that sample point of 5. Another part that you do not get that easily from real-time signal monitoring is, and it's only applicable to parallel execution, is you get information about the top processes, so which processes were involved when this activity took place. And in principle this can be either one or many of these parallel slaves, or the query coordinator could also show up here if we had some activity sampled for the query coordinator itself, which can be very helpful to spot, for example, that there might be a problem with some work distribution problems, like here where we can see that only this P002 is active all the time, whereas P000 and P001 of this set obviously are not active, which we can also see here, if you remember from the previous part of this tutorial. See here reflected in this breakdown of the information that P002 had to work much more than the others in this set, and this is then again reflected here, so that we see here is P010 and 2 active all the time. So this looks like a good distribution, or here we see 3, 4 and 5, so the other set is active here, pretty evenly distributed the work. So here we have a pretty even distribution of work in the other set, and here we have obviously a time and a start where only one slave of each set is active, and you can see here this effect that here's only one slave active of one set, and this looks more like such a round robin activity. So sometimes 3, sometimes 4, sometimes P005 is active, whereas this here from this set only this P002 is active. So this is a typical pattern when the work distribution goes wrong, then only one or only few slaves are actually active out of one set, and the other set is basically waiting for offloading the data, exchanging the data with the other set. And since they have to wait for this single slave to process the data, they basically just can hand over the data in turns. So either one of them is just active and the others have to wait, and they basically are stuck. So this is what it would look like if you have a work distribution, a redistribution, uneven redistribution. And here is a part of the execution where we can see that again all 3 of these members of this set are active. So here the problem obviously is no longer occurring. Why is this so? In this case simply it's because now the second DFO tree starts and the first DFO tree has completed. So this is then the part 2 of the execution plan, this DFO tree number 2, and that's the reason why we have here now a good distribution again. Yeah, depending on the version, some of these columns here might be missing, and there is even more. From 11.2 on, we even get I/O figures. So for each of the samples, we get information about read requests per second, write requests per second, read bytes per second, write bytes per second, and so on, and even the average and middle value for the request sizes. So we can see here, for example, that the read requests take place here at a size of 248K, whereas the write requests take place at 1 megabyte per request. So there's a difference in the I/O request sizes for reads and writes in this case, which is very like the pattern that belongs to the temp activity here, the direct path read write temp. In later versions of Xplan-Ash, this is not the latest version here, this sample is already a little bit older. In later versions, some of these columns will be missing. You will only find the per second information, and no longer the not per second, which show only the aggregated value, which is not that helpful. Therefore, I changed this in the more recent versions that you only see the per second information. In 12c there is this new logical I/O from cache information as an extra column in active session history. So this is specific to 12c, where you see this read mem bytes per second column then. Another information that is not that obvious from this report here is by default this section here will have at most 100 buckets. So if there are more than 100 sample points available, then Xplan-Ash will start to do an aggregation so that you basically end up with at most 100 rows here. So one of these entries then will be a summary of multiple sample points, and the values will then be averages and middle values. So that is the point why this is called average active sessions. In this case here, since it just took 72 seconds and we are in the current VDOLA active session history source mode, each sample point corresponds to exactly one row here. But if we had more than 100 seconds, or in the case of the DBA HIST active session history view, more than 100 sample points, so more than 1000 seconds of runtime, then this here would, as I said, would then start to aggregate multiple sample points into one row. What else is interesting about this section for cross-instance parallel execution? Again, this section will look a little bit differently. Here you basically get one row that is the global activity, and then you get more rows per sample point that correspond to the activity on instance level. So basically each sample point will be broken down, or each row will then be broken down into as many rows as there are instances involved for a cross-instance parallel execution. And you always have this global row, which is a summary of the total activity across all involved instances. So this looks a little bit more messier than the single instance. Maybe I might change this in future, that you get basically two sections, basically one global and one per instance. But for the time being, this is all into one section. So you have this global and this instance specific activity for each sample point, respectively each bucket, if it starts to aggregate. Apart from that, it's basically the same information, just the different levels. Yeah, it's more or less the same. Comparing this to the real-time SQL monitoring, we have this execution phase here. This is also specific to the 12C real-time SQL monitoring report. I think this is the different DFOs then, along with the plan line where this DFO belongs to. This is nothing that you will find here. In principle, yeah, with this top active plan lines, you can basically then see which DFO is active. So line 23 is then obviously this DFO here. Which is DFO number 1 here. What else? My plan line I've already shown. Yeah. So, yeah. So in principle, this section here is corresponding to this section here of the real-time signal monitoring report, along with this PGA, temp, and I/O stuff on this metrics part here. So basically, it covers both. One final thing for this section, what is important to understand in case of recursive activity, Explain-Ash treats this differently from what real-time signal monitoring does. This is a serial execution here. We can see this here. So there is no parallel execution involved. And in principle, then in the activity timeline, we either see then one active session or no active session, 0 active sessions. And this can now have different meanings. One obvious meaning would be that we are in the fetch phase of a select, and this is actually application think time. So the client is not actively fetching data, but is doing some other computations, and therefore is busy doing other things and does not fetch more data from the database. This is one possibility why you see this activity pattern here, so that you have 0 active sessions. But in this case here, it has a different root cause, a different reason, and that's why I mentioned this again here. You always should cross-check this with this so-called other activity section. So we can see here that we have according to real-time signal monitoring, we have a total database time of 65 seconds. But out of these 65 seconds, this SQL ID here that gets analyzed, so this SQL ID here that gets analyzed is only active for 30 of these seconds, in this case 30 of these samples. So that's the reason why we only see basically 30 times that here is some activity taking place in the activity timeline. But for those seconds here where no activity is shown, this doesn't mean that this is application think time, but this is where this other activity here, this 35 seconds, takes place. So a different SQL ID, in this case I think this one here, this recursive activity is taking place. So the database was actually active, but it was a different SQL ID. And since this is a different SQL ID, it doesn't show up here in this activity timeline. So but the point is, you should always cross-check what kind of other activity the Explain-Ash report shows. In real-time signal monitoring, this looks a little bit different. You see here also basically these gaps in activity, but in this case you see here that this SQL ID here is shown when this SQL ID here wasn't active, then this SQL ID was active, which in this case means then this recursive activity. In theory it could also be a different cursor, different open cursor where this client fetches from, but here it is a recursive activity of some PL/SQL function called from this SQL execution. And real-time signal monitoring manages to show this in a single graph, which is probably more helpful than what Explain-Ash does, but in case of Explain-Ash, this recursive activity here is shown in this other activity. So whenever you see here significant time spent in this other activity section and this other activity details, you have to be careful when interpreting this activity timeline based on Ash, because it will then have these parts where this information about the other activity is not included here in this graph. So in order to be able to distinguish between application think time and other database time related activity, always cross-check with the other activity section.